Okay, so one of the types of problems that is on your review and will certainly be on your 9-week exam too is if you look at page 400, and Roderick, you and I worked on some of these today. It's problems like 43 to 58, specifically like 43 to 46. So let's look at those. The big thing about these problems is people tend to basically misinterpret them, not know what they're supposed to do. And so I want to make sure you do know what you're supposed to do when you read a problem like this. Generally, it'll say something like, find, this one says, let me just go back. These say, find the exact value of each of the remaining trigonometric functions of theta. So in other words, like if they give you a number 44, you're given the cosine. And you're supposed to find everything else, the sine, the tangent, the cotangent, the secant, the cosecant. Okay? Now on your midterm, you won't be asked for 5 different answers on one problem because it's multiple choice. So it might say, here's the cosine, find the sine. Here's the cosine, find the cosecant. Here's the cosine, find the tangent. So it'll be something like, if the cosine of theta is 3/5, and theta is in quadrant 4, find the tangent of theta. Okay, so let's do that. So I'm going to do number 44. We'll just go ahead and find all of them. Okay, it says cosine of theta is 3/5 and theta is in quadrant 4. So here's the part you have to know. You have to know that this means, first and foremost, that you have to draw a picture. And the picture has to start with X and Y axes, and then what you do is you go to the origin, and you're going to start at the origin. And since it says quadrant 4, you're going to draw a segment that sticks out into quadrant 4 from the origin. This is also known as the terminal side of your angle. Okay, this little segment you just drew. So I knew to start at the origin and go out into quadrant 4 because they told me that my angle was in quadrant 4. So the next thing you do is you finish the triangle, and make sure that when you complete the triangle, you do that by going back to the x-axis from that point you just finished at. In other words, you drew from the origin out to this point, and then go from that point back to the x-axis, not to the y-axis. And that's the right angle. So here's my triangle. Now in this little picture, this is theta. And I should have mentioned, here are your quadrants, of course. Okay, theta is always the angle that is closest to the origin. So what I have here is, if cosine of theta is equal to 3/5, then think about SOHCAHTOA. Cosine is adjacent over hypotenuse. So I'm going to label the picture with those numbers. The adjacent side for this little angle right here, remember that the angle is always between the hypotenuse and the adjacent. The opposite is the one over here that doesn't touch my angle at all. Okay, so adjacent is right here, hypotenuse is right here, and this is opposite. So if cosine is 3/5, that means this side is 3 and this side is 5. So I've got 3 here, 5 here, and I have to find the missing side, the third side of the triangle. I'm going to use the Pythagorean theorem to do that. So remembering the Pythagorean theorem, it's a leg squared plus the other leg squared equals the hypotenuse squared. I like to put it that way instead of a squared plus b squared equals c squared, because people forget the c has to be the hypotenuse. So this is 3 squared plus, I don't know the opposite side, so I'll just call it x, equals hypotenuse squared. That means 9 plus x squared equals 25. I'm going to subtract 9 from both sides. X squared is 16, and that means that x is 4. Get that by taking the square root of both sides. So I have 4 here. So I have 3, 5, 4. Now the next thing I have to be careful of is because this is in the fourth quadrant, I will have a negative, excuse me. Think about going to this point down here from the origin along the horizontal and vertical lines. To get from here to there, I go to the right 3, that's positive 3, and down 4, so this is a negative 4. Another way to know that is that all the points in the fourth quadrant are positive and then negative because you go to the right and down to get there. Okay, so now I know all 3 sides of that triangle, and I'm going to use all 3 sides to find all the rest of the functions. So I already knew the cosine. The sine is opposite over hypotenuse. The tangent is opposite over adjacent. Now I put these in this order specifically because it makes a lot more sense to me to do the ones that go together next to each other. In other words, cosine is the reciprocal function of the secant. So that means if I take this and flip it over, I have the answer for secant. Sine goes with cosecant. So if I take this and flip it over, I have cosecant. And they keep the same sign they already had in terms of positive and negative. If it was negative, it's still negative when you flip it over. Same thing here, cotangent, reciprocal of the tangent, and there are my answers. So if the problem asks me for the cosecant, there it is. If the problem asks me for the tangent, there it is, and so on. So that was number 44 on page 400. Let's go ahead and do another one real quick. Let's look at number, let's see, 46. Okay, that way you guys can do 43 and 45 and check them in the back. Okay, so again, you always start by reading what quadrant this is supposed to be in. Number 46 says the sine of theta is negative 5 over 13, and theta is in quadrant 3. So I start at the origin and I go out into quadrant 3, and then from that point I drop a line back to the x-axis. Okay, so if the sine is supposed to be negative, this is what they give me, negative 5/13. They don't show me whether the negative is in the numerator or in the denominator or what. First thing is, you will never put a negative on a hypotenuse. The negative is always going to be one of the horizontal or vertical segments. It's never going to be on your hypotenuse. So it's never going to be on like the diagonal. So think about the third quadrant. In the third quadrant, everything's negative because you go to the left and down to get there. All right. So here's my angle. That means this is my hypotenuse. Right here's the hypotenuse. So this is the adjacent. So this is the opposite. And since sine is opposite over hypotenuse, opposite 5, hypotenuse 13, there's a negative here, and whenever I find that number, there's going to be a negative there as well. I'm going to put it there. When you're doing Pythagorean theorem, there are no negatives because it's just about lengths. So once I find what goes here, that's when I'll put a negative on it. So let's go ahead and do Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So here's a leg. Negative 5 squared plus the other leg squared equals 13 squared. 25 plus, let's call it x. Subtract 25 from both sides, and I have x squared is 144, and aren't I lucky? That's a perfect square. It's 12. So this is 12, but again, because it's in the third quadrant, this is actually a negative 12. That's going to matter when I'm finding all the other trig functions. Okay, so let's go ahead. We've got sine opposite over Cosine is adjacent. My adjacent side here is negative 12. And tangent, opposite over adjacent. In this case, that's negative 5 over negative 12. Since they're both negative, that makes it positive. All right, so let's see. Sine goes with cosecant. So let's just flip that over. Cosine goes with secant. So let's flip this over. And tangent goes with cotangent. So let's flip that over. And there we go. Remember on this video, if you need to pause it because you're trying to think about what I'm saying, do that. Just pause as you go, think about what I'm saying, make sure it makes sense to you, and then you can restart the video. That's the beauty of learning in a video.